recording now. So I have these photographs, okay, that I'm going to be looking at. And as we've talked about, right, if you have this group of 4 people and you want to align them up in a line, okay, how many different ways, right, can we create this photograph? So we have 4 people, everyone needs to be in it. How many different ways could we have them be in this photograph? So if we look at this, is there are 4 slots, right? And we're trying to determine how many different ways can I arrange the people. Well, how many different available people are there that I can put in my first slot? Right? I could put 4 people in that slot, right? And then for my next slot, if I've already used 1 up, now I only have 3 left. Okay, for my next slot, I only have 2 left. And in my final slot, I only have 1 left. Okay, so our fundamental counting principle that we talked about before says if we multiply all these together, right, we can determine the total number of different ways in which we can arrange these people. So 4 times 3 is 12. 3 times 2, or sorry, 4 times 3 is 12. 12 times 2 is 24. Times 1 is there are 24 different ways. But it says how many different photographs can be taken if we add another person to this group? Well, now, right, we're talking about 5 people being selected in these different areas. So if we write this out, right, now we have 5 slots. So 1, 2, 3, 4, 5 slots. Right, our first one we would have 5, then 4, then 3, then 2, then 1. So if we multiply these together, we get 5 times 4 times 3 times 2 times 1, and that gives us 120 different ways, okay, that we could take this group photograph. Okay, so then it says, can you make any conjectures for the number of photographs that you can take with n people? And it says, can you make an argument that your conjecture is correct? Okay, so what we want to do is think about, okay, so if we notice this, if you had 4, it was 4 times 3 times 2 times 1. Okay, if we had 5, it was 5 times 4 times 3 times 2 times 1. Okay, so then what can we say the number for the number of photographs that can be taken if there are n people? Does anybody have any thoughts that they'd like to share? Silence. All right. So hopefully we notice, right, that we take the number of people that we're looking for, right, and we just kept multiplying down, right? We just kept going down 1 and multiplying by that because that's how many people are left for the next spot. So then the number of photographs that can be taken with n people, right, is I take n and I multiply that by n minus 1 and then multiply that by n minus 2, and then I go all the way down to where there's just 1 person left for that last slot. Any questions about how I came up with that? Of course, this would have to be in parentheses. Now, there's an actual mathematical term for this that can be used, and this is what's known as, you can write this as n with an exclamation point after it, which means n factorial. Okay, so this is n factorial. So that's going from n and multiplying by each number from n all the way down to 1. And it's n has to be an integer, and then it's going to be each integer less than it down to the number 1. Okay, so that's where this factorial comes into play. Okay, so then next it says, suppose that you have a group of n people, but you only want r of them at a time to be in your photograph. How many photos can you make? So sometimes this is helpful to think about like specific cases and then be able to try and generalize it more. Okay, so let's say that we have 5 people, okay, but we only want 3. Okay, so then I would have 3 slots, right? And I have 5 people to choose from for my first slot. I have 4 people to choose from for my second slot. And I have 3 people to choose from, okay, for my third slot. So now I only have 5 times 4 times 3. Well, let's take a look at another example. Let's say I have 7 people and I want to have 4. Okay, so if I go 1, 2, 3, 4. So I would have 7 for my first, 6 for my second, 5, and then 4. Right? So I would have these really big numbers, but the key is how can I go from here, okay, to an actual formula? So up here I had n factorial was how many if I needed to use all 7. But now what happens if I only need to use 4? Well, if I look at this, right, I have 7 people, I need 4. So how many am I not using? Well, then I'm not using 3. Well, notice how I cut off from 3 down of my factorial. Okay, same thing here. I have 5 people total. I'm using 3 of them. So 5 minus 3 means I'm cutting off 2. And when I figure out how many total combinations I can do, I've cut off my 2 down. Now, when we're cutting people off, right, when I'm saying I'm cutting them off, right, what are ways in which we can get things to kind of go away, right? Well, if something is divided by itself, right, it goes away. Okay, so if we have n people, right, then we want them to be. So let's think about this. We said originally if you had 7 and you wanted all 7, that would be 7 factorial. But we said we need to cut off or get rid of from 3 down. So that would be 3 factorial that I need to get rid of. Right here, this would be 5 factorial for the total number if I wanted all 5, but I need to get rid of 2 factorial to get rid of the ones that I'm not using. So if you're struggling to see how that works, right, we need 7 times 6 times 5 times 4 times 3 times 2 times 1 would be all of them, but I just need it to be the 7, 6, 5, 4. So that means I need to get rid of the 3, the 2, and the 1. So if I divide by that 3 factorial, it would cancel those out, and I'd just be left with what's left. So now if I want to look at that in terms of n, right, people, but we only want r of them, well, if I try to generalize this formula that I've looked at some examples right here, right? If I have n total people, so that's n factorial, and then how do we get to this 3? Well, I said, right, if we took our 7 minus our 4 or our 5 minus our 3. So if we take them at n minus r factorial, that should give us the same 7 times 6 times 5 times 4. Now, if you have a graphing calculator, you actually have the capabilities of doing this on your graphing calculator, but you don't necessarily have to have the graphing calculator. It just helps you this formula is built right in where you can put in the n and the r. But we can talk about that a little bit more later. So any questions about this, right? So we have n factorial over n minus r factorial ways of doing this, okay? Or, right, how many different photographs can be taken? So you have n factorial times n minus r factorial photos. Okay, that's how many different unique photos you can have. Any questions on that? No questions. Do you think there's something darker you can write? Are you still having a hard time seeing it, or was it just that it was the focus was wrong? Because on my screen, it's pretty clear.
Yeah, that's better. Sorry, it was like I couldn't like tell what you like. It was like super like light and like
Okay,
yeah, it was
no,
hard
that's
to see.
fine. I
Sorry.
mean, definitely let me know whenever there's an issue.
Okay.